Being able to lint your entire code base in 5 seconds is amazing when it used to take a minute, but you will eventually have to run type checking on that code base anyway. So it's a series of successive bottlenecks. And although native speed linters have eliminated the first and by far largest of those bottlenecks, there will be other bottlenecks down the road. My personal theory, my headcanon, is that users don't need need it all to be 20 or 50 times faster. They just need it to be not slow.
Welcome to TypeScript FM, the friendly podcast for TypeScript developers where we bring you news, updates, and interviews from the community with plenty of tomfoolery sprinkled in. I'm your host, Kamran Ayub, and I'm joined by my co-host and best bud, Eric Onerheim. Together, we're the two TypeScript fools. Welcome to the show. Welcome to the show.
Welcome to the show.
We have a guest today, a repeat guest. We're joined again by our great friend, Josh Goldberg, whom you may have heard previously on one of our other episodes talking about the vanilla TypeScript experience. So if you haven't listened to that episode, go listen to that. But in today's episode, we're going to dive deep into the state of linting, because this is something that me and Eric are total fools about, and we need an expert on to talk about. What should we be doing with linting? Why are there so many options? So, Josh, do you want to just give a really quick intro to yourself, just in case listeners haven't heard your previous interview?
Sure. Thanks for having me. Hi, everyone. I'm Josh. I'm a full-time independent open source maintainer. I work on a bunch of projects in the TypeScript ecosystem. The most notable ones for this conversation are TypeScript ESLint and ESLint. ESLint is the long time, most common by far, linter for JavaScript, TypeScript, and similar. And then TypeScript ESLint is the tooling that lets it work on TypeScript and also adds in a lot of really good features and rules for TypeScript code.
Awesome. So why are there so many linters out there right now? Why hasn't one just won?
Well, one did win for a long time, right? ESLint?
Mm-hmm.
I'm glad you asked. I think what happens a lot of the time is you'll have one clear winner in a particular area of tech, let's say linting. Time will go on, and then we'll learn that there are more things we want to do with it, but it's not clear what the right or best way to do those is. So we'll branch off, we'll experiment. People will be annoyed because there'll be 5 different options they have to choose from, and they're all subtly different in different ways. And then eventually we'll have 1 or 2 main ones again. And we are, I think, right now very much in the early stages of the experimental try new things phase.
I'm going to start actually with a dumb question, perhaps, which is TypeScript already gives me type safety. Why would I adopt a linter in the first place? What does it give me that TypeScript by default doesn't give me?
You don't have to, but it is useful to. There's stuff it adds on top. In words, 1 each, TypeScript is a can, linting is a should. TypeScript checks if this thing you're going to do is literally going to definitely crash, or if it completely mismatches. You stated your intent here with types, and then your usage there with the values mismatches. Linting is a little more soft. Linting is much more configurable. It's a bunch of different rules. Each one of those rules enforces something that might be type safe, but is probably not what you meant to do. Like maybe you made a variable and you never used the variable, which is amusingly a lint concern that TypeScript can also check for. Or maybe you have an asynchronous function and you call it and you don't handle the return of that. Maybe you forgot to await or some such. Well, linting is very, very configurable and allows you to say what you want to do in those scenarios. If you say want the linter to yell at you and give you a yellow or red squiggly.
Yeah, I've definitely had super heinous bugs with the floating promise problem that you described there. Like it's just like some weird timing bugs. And you're like, it mostly works, but sometimes it doesn't. And then you're like, oh, I forgot to await something.
So we've got a lot of different lint tools. Some of the ones that we've talked about on the podcast recently include the Biome, which is sort of the ESLint Rust-based alternative, Dino Lint, which is built into Dino, OxLint, which is sort of new on the block, experimental TSGo Lint, that's like very experimental, and TSL is another one that we recently talked about. Do you want to maybe give listeners an overview of like what's going on here? What is the state of the state? And like which ones should they be paying attention to? And your own project, too, that you're working on.
Yeah, that's good context that users, readers, listeners should have, that I am biased here. I work in the space. I have my own horse that I'm betting on. I think there are sort of two main camps that Linter experiments or Linters are trying to adhere to. One is the traditional write-in in JavaScript or TypeScript camp. That's ESLint, TSL, TSSLint, and Flint. TSL and TSSLint are two variations on working much more closely with TypeScript as written in TypeScript and reusing a lot of info there for performance. Then there are the native speed ones, Dino, BiomeLint, OXLint. Those are abandoning the niceness and convenience of writing in TypeScript for TypeScript developers in favor of absurd, shocking improvements in performance, 10, 50x performance improvements. Personally, the one that I'm working on, Flint, is kind of a hybrid. The intent is to write the main coordinating logic in TypeScript, but then defer to a native speed parser, ideally TS-Go, and then also native speed type information. But it's really unclear at this stage what those trade-offs will end up being like, if it will be worth the abandoning of TypeScript convenience for the performance in all or many cases.
Yeah, that was one of the things that I was opining on earlier with Kamran before the show. I was like, well, it might be cool to like check out like OXLint or Biome, but if it's not like built in, like am I writing like Rust to add a rule that I want to add? Like that doesn't sound like fun. Or maybe it does to some people, but
To some
not
people,
to me.
it sounds like a great time. Yeah. And there are a few different strategies they have for this. One is allowing you to write your rules in JavaScript, TypeScript, and just doing really nice performance shenanigans to make it fast. Another is providing a DSL, like a domain-specific language, like GritQL, to let you write lint rule equivalents. So I think right now, if you have a giant code base and you want to lint it all fast, you basically have to use a native speed linter. But I'm hopeful that in the future, we'll be able to kind of work around that and maybe use fancy caching or other techniques to make it a little easier.
Why is there a split between like a regular linter like ESLint and then TypeScript-specific linting? So what does the TypeScript-specific linting gives us on top of ESLint?
There are kind of two stages to that question. First, there's the syntax support of ESLint natively is very intentionally a JavaScript project. It doesn't add in user-line extensions like CoffeeScript or TypeScript or experimental syntax. So that's stage one. So you need to use an external parser, i.e. TypeScript ESLints, to parse TypeScript. But then on top of that, there's type information. Traditionally, lint rules only work on one file at a time. They don't know what's coming from other files. They don't know if you import a function from utils, whether that function is asynchronous or takes in arguments or whatever. The TypeScript type information, though, allows lint rules to be much more powerful at the cost of slowing you down to whatever speed TypeScript is running at, which until TypeScript Go is stable will continue to be a lot slower than what many users would prefer.
So
Nice.
The TypeScript linting gives us type-aware linting so that we can do styling rules and code rules based on the actual types that we're dealing with and not just what we see as like just the regular syntax, without types.
Yeah, exactly.
One really interesting project that hit the blue skies was the TS-Go lint that just hit, I think, like a week or so ago. And that's pretty wild. How are they doing that? Are they just grabbing the TS-Go? Because as far as I know, there is not the same compiler API yet in TS-Go as there is in TypeScript. So I'm really curious how that's even working.
Yeah, it's fascinating. It is this kind of skunkworks project from one of the members of the TypeScript ESLint team, this wizard named or user named Avred. When we went public, I had the most recent commit on the repo because I made a small docs change and then people gave me credit for it, which is absolutely incorrect.
Yeah, sorry about that.
I was like, oh, good. I know Go now. This is wonderful. The project uses some unholy, really interesting wizardry to kind of embed and work deeply with the internals of TypeScript Go. I'm not extremely familiar with the specifics, but I can tell you that it is very much a research experimental project. It's not stable. It doesn't have a lot of lint rules fleshed out. Avred mostly wrote the typed linting rules in it just to see how this integration could work. The conclusion was, yes, we can get an absurd native speed linter using type information from TypeScript Go, which is great, wonderful finding. But the interoperability of it with rules written in JavaScript or TypeScript, or even importing, your utilities, your design system tokens or whatnot, is because of the nature of Go and Go's ecosystem still kind of shaky and hard to work with.
So it's kind of like maybe a preview of the future, but I don't pile on to that yet.
Yeah. What's happening right now is that at least the OXC project is taking it on as a, we'll use this and we'll work on it project. Because ESLint, which is the native speed linter, doesn't have typed linting, and they really want it to. And I think that that's a really natural way to explore, kind of using TypeScript Go directly. So one interesting thing is Biome. Biome is writing their own TypeScript inference, not a type checker. They're not implementing the full assignability, is this object assignable to stuff, just the what type is this APIs. I think that's really interesting. I personally am not super optimistic about it. And again, this is my bias here. Please don't take this as fact. I think that lint rules are going to end up needing a significant amount of TypeScript's assignability checks. That's actually an API we started using in TypeScript ESLint. For example, detecting whether a constituent of a union type, one of the things in a union type, is necessary or completely a subset of another requires that. Also, even that much of TypeScript is really hard to implement when you've got conditional logical types. But the nice part of it is if they succeed in writing most or all of TypeScript's inference in Rust, they will have a much easier time writing lint rules using it, and it'll be very fast. So, pros and cons.
Oh, I think this brings up a good question, and you wrote a whole series on this, so we're really interested to get your thoughts on this. What does like a modern architecture look like for a linter that gives us kind of the best of both worlds? Because in my head, I'm thinking what is best for me as an end user is something that is super fast, has type-aware linting rules, and allows me to write rules in TypeScript and not have to learn another DSL or learn another language. So is there something that gets us our cake and lets us eat it too?
No. Not in this calendar year.
Not yet.
I hope and believe that eventually, within a few years, that will be the common practice. My personal horse I'm betting on, Flint, is a fast, friendly linter, et cetera, branding. I think that's going to be it, but it's hard to say. I think there's also an alternate possible future where they figure out the interop story for something like Rust or Go really well, and the performance slowdown of calling to TypeScript rules, let's say, within your Rust project is nice. I also think that caching is going to become more and more of an important performance concern with linting. For reference, ESLint cache is just fundamentally broken and does not work with cross-file linting. It only recognizes one file at a time. Well, typed linting is cross-file. Import analysis, like from the import plugins, completely break that. So my hope is that as we're able to figure out linting caches that work cross-file, the performance of both sides will improve. So whether you're using a native speed linter, which is so absurdly fast, it runs faster than your cache retrieval, or if you're on the traditional one, it'll be a lot faster there.
Where is the bottleneck right now in like type-aware linting? Because I know we talked briefly about it, and we got confused with like reusing the AST, which is what TSL does, versus like actual caching of type instantiations and stuff like that. So I was hoping you could give us and the audience a little bit of a deeper dive into like how the linting process works with TypeScript and where the bottleneck really is.
Yeah, happy to. Please note that this is not a single sentence answer. This will take a little bit of nuance. Right now, the way that TypeScript ESLint and typed linting rules in ESLint work is you parse two ASTs. We call directly to TypeScript to use the TypeScript API to create the TypeScript shape of your code. Then we recursively transform each node and its children into the equivalent structure that ESLint recognizes, called ESTree. People see this and they go, oh my gosh, you're parsing two ASTs. That must be the bottleneck. That has never been the bottleneck, and it will probably never be the bottleneck. The bottleneck is calling to TypeScript for type checking, for type inference, because determining the type of things requires a lot of computation. And TypeScript is not written in a native speed language, so it operates at JavaScript speed. So right now, I've seen frequently, people will proclaim, look at me, I switched off my linter from ESLint to OXLint or some such, and I went from 30 seconds of linting to 3 seconds. And 9 times out of 10, the reason why it was 30 seconds was because they had typed linting, and when they remove type linting, they go down to 5 or 10 seconds. So the bottleneck really is type information. That's the thing we need to figure out to make linting fast and powerful for the future.
Awesome. Yeah, I can see that too, because if you're only considering one file at a time, you can make that very embarrassingly parallel. You can just, how many cores you got? All right, let's go chew on all those files. and then come up with something. Yeah, I can definitely see how that would go much faster, especially like in a native speed thing where you can just, do, cache-friendly data structures really easily that you can't really do in JavaScript reliably. You can try, but, you might be fighting that battle for a while. But yeah, you can definitely do a lot more in native for that. I can definitely see.
These different lint tools that are coming out, the native ones that we're talking about, many of them are written in Rust, but I think the TS-Go lint, the experimental one, is written in Go. How do you see like Rust-based linters compared to Go-based linters and like writing rules for those? Do you have thoughts around the language that's used to write these native linters?
I personally don't think we should be writing the linter in Rust or any other non-JavaScript TypeScript language. I think the linter is a really important onboarding venue line thing for people getting into dev tools. I think it's unfortunate to restrict people to make it that much harder to get into things like ASTs. There are some high-intent folks who don't mind that that's new and confusing and will just go no matter how hard it is because they want it. But a lot of folks are very, dip the toe in the water first. They don't want to deal with any barriers to entry. So for me, there's kind of, it's already not what I want. It's a point of necessity that a lot of projects need that speed and have to do it there for now, but it makes me unhappy. That being said, I think out of all the languages that go against my own personal opinion as stated, Rust is the best. Just Rust has the best interop with other JavaScript ecosystem things. There are so many tools already written in it. It's kind of unfortunate that Go was just by far the best candidate for writing TypeScript or porting TypeScript to. It made a lot of sense. And as a result, I think it makes a lot of sense to integrate with Go. But I don't know, man. If I were to write a native speed linter, it would definitely be in Rust.
Yeah, I'm really curious to see what the ecosystem evolves here around like, perhaps there is like a DSL that you can write that's like JavaScript-ish. And like it looks like JavaScript, but it's really, a separate interpreted language or even a compiled one that, kind of like how Cloudflare workers work. They compile like a subset of JavaScript into like WebAssembly and then run it. Maybe there's like a venue there to like kind of get your cake and eat it too. But then you don't get everything that you could possibly want because you've invented a subset of JavaScript. I don't know.
Well, I mean, going back to what Josh was educating us about before, like where the bottleneck is, to me, this is also my personal opinion, I don't see why you wouldn't want to just make the linter in TypeScript and then just rely on the TypeScript native, whatever API is going to be coming out, to go get the types. Because that is what is going to speed it up. Like, it sounds like it's not really the linting core code that really needs to be sped up. So I don't know how much of the speed up in the Rust-based linters is really that it's written in Rust versus like JavaScript. I don't know.
Yeah.
If you have any insight on that. Like if you were like take TypeScript out of the equation, is like Oxy or Biome really that much faster than ESLint? Maybe it is. Be curious on like what the actual speed up is.
I look forward to my friends on those teams yelling at me after this episode. No, they really are that much faster, even without type information. Like they are absurdly good pieces of engineering, really. I think the difference is nowhere near as what users are commonly experiencing. The difference between slow typed linting versus fast untyped or fast native speed typed in linting, but it's not as impactful as it seems at first. I will also make the point that being able to lint your entire code base in 5 seconds is amazing when it used to take a minute, but you will eventually have to run type checking on that code base anyway. So it's a series of successive bottlenecks. And although native speed linters have eliminated the first and by far largest of those bottlenecks, there will be other bottlenecks down the road. My personal theory, my headcanon, is that users don't need it all to be 20 or 50 times faster. They just need it to be not slow. Like there's the analogy that performance is like oxygen. You only care about it when you don't have it. Well, once you have enough oxygen, you're fine. You don't need hypersaturation.
There is definitely a level of like, this is good enough. Like, certainly I had this conversation with a few folks, but performance is kind of like, it's kind of a hell of a drug because you can keep going like until to the purest insanity of making something fast. But there is a point where it's like, this is good enough. Like where it's imperceptible to humans.
Yeah.
Yeah, I mean, if I can build and lint my TypeScript project in 5 seconds, both like in total, like that's good enough for me, you know. That would be a really big project. And like big teams, like when we were working at Target, we had like 80 packages in the monorepo. So like there, yeah, speed is a concern, right? But after a certain point, it's good. You know, like we were able to get the full monorepo build down to like 30 seconds, and that was pretty good. That shaved off, you know, minutes off of our CI build time. Yeah, if we could get that down to 5 seconds, you know, even better. But like less than 5 seconds is like diminishing returns, right?
Yeah, that's a very senior engineer perspective, that it's not about whether you want A or don't want A. It's where you allocating your resources. And performance should get a significant amount of those resources, but certainly not all of them. There are other points on the linter that I also think we need to be iterating and improving upon, like the core user experience, the practices around lint rules, the adoption story for folks who hate linting and are just being forced to do it, or even whether they should be adopted in the first place. That all this stuff is actively growing and we're learning around it. One of the really key things that we're making improvements on these days.
Yeah, definitely.
So we do have this division between the linting tools, ones that are stable and ones that are unstable. So I guess as a end user, as a listener, if I'm starting a new project, like where would you recommend I look at if I kind of want faster speed, but then, for example, I want the no floating promises rule to like work too on my code base?
Pick one or pick one or two of two. If you want fast linting, like really ultra fast, like absurdly fast, lint your entire code base every keystroke, use something like Biome or ESLint. If you want typed linting, if you want powerful type rules that are stable and well supported, then use ESLint with TypeScript ESLint. If you want both, you can use both, actually. You can set up both linters. In fact, in TypeScript ESLint, we even provide a config that turns off all the non-type aware lint rules so that you can just run the typed ones as like a step in CI instead of locally or whatever it is your project is. But yeah, really, I hate to say it, but there's no perfect solution. There's no pick two of two with only one linter right now.
Bummer, dude.
Sorry. I mean, look, ESLint, as you said, they're trying out type linting, and hopefully, maybe soon they'll have it stable. But there are quite a lot of rules out there, including in TypeScript ESLint, and also userland plugins that people like. So it will be, a non-trivial amount of work to get parity. And maybe it's helpful for users to hear this explicitly. The main difference with typed lint rules is that they use type information, which is cross-file. That's something that is much harder to implement, but is much more powerful. It allows you to do things like we've been talking around no floating promises, checking if you're looping over an object's keys using for in versus for of entries, or looping over an array with for in, which is weird. And then what happens in a lot of enterprise code bases, larger companies, is they write custom rules to enforce company-specific things, and they use type information to determine, say, is this an instance of a particular object or class that needs to have these validations? So you get this weird kind of unfortunate linking of the larger a code base is, the more it needs these ultra-fast linters, but also the more likely it is to additionally need typed lint rules. And I really find that irksome, because it would be nice if we could go the opposite. But it's really painful for a lot of companies now. They are spending a lot of money to run, say, ESLint with TypeScript ESLint, which is not made for the performance of lint rules, or performance of typed lint rules, rather.
In your estimation, what do you think that like the biggest bang for buck type aware rule is that you see around? Is it the no floating promises? Certainly that's one that comes to mind for me, because those bugs are super heinous. But I'm curious if there's any others that come to mind that are like, oh, this is a golden rule that you should probably have turned on.
Yeah. I have a bunch of golden rules, but just speaking in families, yeah, the rules around asynchronous code, I think, are the highest bang for buck, just in terms of the amount of bugs they catch. I caught a bug in Next.js, for example, just by turning on no floating promises. The other big one is the family of no unsafe rules. No unsafe any in member expressions, or like no unsafe call, like calling in any like a function. All these rules that stop you from using any. There is a non-type aware rule, just a standard no explicit any, which stops you from writing any. But even with that rule on, it's still really easy for any's, the unsafe things, to come into your code base. So having rules that make sure you're not like relying on the property of the result of JSON.stringify or something are really handy, and I've seen catch a lot of bugs too.
Yeah, for sure. Like anything over the network should be treated highly suspect.
Is there anything else you think? relevant for like listeners and trying to figure out their lint situation. Because what I'm hearing is that if I want something super stable, like ESLint and TypeScript ESLint are my go-to, and I get my type-aware linting rules, but it is going to be a bit slower. However, I could just choose to run those in CI, and then it's not like a huge deal. If I want something that is really, really fast, and I get a little bit of type-aware linting, I could choose Biome v2. And if I want very fast linting, but no type-aware linting rules quite yet, I could do ESLint and then hope that, hey, in the future they're going to be adding type-aware linting. So that's kind of what I'm hearing, but I'd be curious sort of what your thoughts are.
Yeah, I think that's pretty accurate. I've been seeing a lot of really exciting, encouraging posts from the ESLint team around what they're currently working on, typed linting, type-aware. I would say we haven't exclusively only been working on the large-scale architectures. The Linter world has learned a lot around documentation and user behavior and how to roll out these things. And I think the biggest part of that I'm excited about is understanding how to explain to users their relationship with the Linter and the rules. For a long time, we had these big old presets like ESLint plugin Airbnb, which enraged so many people because they would turn on these rules that are completely annoying if you don't have the exact same opinion. So now a lot of people hate linting and post things like, delete your lint config, delete your ESLint config, which is sometimes good advice in certain situations. But I think a good catch-all practice would be for people to think critically. What am I actually getting out of this tool? What am I hoping to get out of the tool? Like, what are the lint rules that sound useful? And then disable everything else. Anything that you don't actually find useful in your lint config, delete it. For example, I personally enabled the Perfectionist plugin. It's one of my favorites. It enables alphabetical sorting of not just imports, but object properties, interface methods. Most people hate that. So if you use a Josh Goldberg project and you don't like it, please just get rid of the Perfectionist plugin. It'll make you hate it if you don't. But really, I think the idea that, I'm in control here. I can turn off rules or disable them on a file-by-file or line-by-line basis really gives you power over the linter and gets it out of your way while still helping it help you.
I think maybe another thing is not enough people are reaching for building their own rules. Like we have in Excalibur, there's a few things where you can foot gun very easily. And we've played around with writing rules to be like, it's basically no floating promises. It's like you created an actor and you didn't put it in a scene, so it won't show up. It won't draw, so you won't see it on the screen. Easy. I do it all the time. And I've written Excalibur code for a decade. So it doesn't matter how long you've been doing a thing. It's very easy to do. And, if you have a rule like that, you can be like, oh, did you mean to do this or not? I mean, because it might not be an error, but maybe it is. Same with the no floating promises. You might be like, okay, I'm going to queue up 10 promises and I'm going to do, promise.race. And that was my plan, but it could be an error.
Yeah. The best laid plans of coders and mice. Strong agree. I think one of the unfortunate side effects of linters being a relatively new practice and therefore not well understood and getting on folks' nerves sometimes is that there's not as much excitement around custom lint rules as I think there really should be. It is much easier than most people think it is to learn how to write a lint rule. They have all these scary acronyms like AST and whatnot that sound horrifying, but honestly, it's a couple dozen lines of code very often. I've introduced people who have absolutely no confidence and who have never worked in any language or dev tooling or anything. And if they can do it, listener, I promise you can do it too.
That's actually a good point. We only very briefly covered this when we last interviewed you, but now's a good time to go a little bit deeper. You have some good resources for if I am in an audience and I want to write a lint rule. Like I'm thinking right now, it would be really nice to write some Excalibur lint rules, but in the past I've only ever written a single rule, and it was fairly complicated because I was copying the React exhaustive depths lint rule. That was kind of a bear. I'm really curious how it's evolved now over time and maybe where to go to learn more.
Absolutely. Thank you. I'm glad you're asking. I'm sure every linter has its equivalent resources for this, but on TypeScript ESLint, we have a blog post called ASTs and TypeScript ESLint, published December 5th, 2022, 4-minute read, where we cover what's an AST, what are the formats, why do we do things the way we do, and then they show you quickly how to make a custom lint rule. In fact, you don't even need to write a custom lint rule to get experience here. There are a few ESLint rules that allow you to pass in some AST selector, like all variables whose names start with capital I, to say ban those things or to give a message saying you should do it some other way. So the TypeScript ESLint blog post, ASTs and TypeScript ESLint, has that stuff, and it also links out to other good resources and next steps that you might want to do. So definitely it is absolutely doable to spend 10 minutes reading or 5 minutes reading and 20 minutes of mucking around to get a custom lint rule.
Sweet. Is there actually like a playground where I could like see the rule in action and like tweak it and see if it's working against like a code snippet?
Don't know that one exists for specifically a custom lint rule, but that is a good idea and a feature request. I don't know anyone's filed that on us. You should definitely file that feature request on every Linter project, including TypeScript ESLint. It's a great idea.
I have a new ESLint rule, like, don't use new date. Don't do it. Like, you get slapped if you do new date or use any of the date things. Make it so that you have to use temporal polyfill or something.
That's a great example of a userland custom lint rule. We would never write a rule like that in ESLint or TypeScript ESLint core because patch just bans something like that everyone uses. But for people specifically who wants to be slapped, as you described, and moved over to the new API, oh my God, that's so nice. That's so useful. Especially if you can write auto fixers or suggestions that do it automatically, switch the two. Oh my gosh.
Yeah, that would be cool.
I'm not too familiar with all the different like plugins and different rules that there are available. It's funny that you mentioned the Airbnb one because that is the one that we used at my last team. So are there any others that you think people should be taking a look at and might enjoy using?
There are quite a few awesome ESLint plugins in the wild that I wish everyone or almost everyone used. There's, formerly ESLint plugin deprecation, which lets you know using type info if you are using something that is marked as @deprecated. Amusingly, that plugin was deprecated because we moved it into TypeScript ESLint core. So now there's just a no deprecated rule. There's ESLint plugin regex or regular expressions, which lets you know if you're doing bad practices, such as security vulnerabilities in your regular expressions, like DDoS or ReDOS, I think it might be called. And I can't tell you what absurdly large number of security reports that are bogus spam would have been caught by that rule. There's ESLint plugin N, short for Node. There's ESLint plugin JSDoc, which has one of the favorite rules of mine that I've ever written, the informative docs rule, which lets you know if your docs string just says the name of the thing, like @param the ID, or param ID. Like, why are we writing this?
Yeah, no tautological documentation, please. That just infuriates me. Whenever I pull that up, I'm like, yeah, no, Sherlock, yeah.
Returns a promise, period. Okay.
It returns. Thanks. Okay, thanks.
In general, I'd say check the list on Dustin Specker /awesome-ESLint. Just Google awesome ESLint. It's a repo that has a list of awesome ESLint plugins and so on. Also, check out the list in Create TypeScript app. That's my kind of TypeScript starter we've talked about that has a bunch of plugins, such as the ones we mentioned, and Perfectionist in the everything preset, and then use which ones you actually want. For kind of more niche use cases, there are quite a few that are really nice. I maintain ESLint plugin erasable syntax only, which forces or attempts to force you to only use syntax that works with TypeScript's isolated declarations, which you've talked about on the show and is just a wonderful thing for performance. There's also ESLint plugin package.json, which awesome fella named Michael Faith and I maintain, that has really nice rules around your package.json file. And then also ESLint core, one of their big initiatives this year has been, since they made the general architecture of ESLint language agnostic, they're writing plugins for Markdown and CSS that kind of do a lot of the same work as the older Markdown Lint and StyleLint projects. So I'm really excited about that landing in ESLint core.
That's cool. Yeah, I can definitely see some opportunities in CSS. Certainly, based on the CSS that I write.
Yeah, agree.
I probably need as much help as possible because I kind of been spoiled by the CS sandboxing that like Angular does. It doesn't infect the rest of it. Just go ahead and slap it out, whatever. It's sandboxed. It's okay. It's scoped.
You don't want to take a look at my CSS architecture or lack thereof.
Yeah.
The biggest air quotes that the world has ever seen around that one.
So with Flint still being in development, that's accurate, right? You're still working on it, and you would probably classify it as not quite stable yet?
I would strongly protest anybody using it.
Okay.
Yeah.
Do you want to give us kind of a date of how Flint is going? And I guess as a user, I would be very curious whether, if I'm using TypeScript ESLint right now, am I able to get Flint as maybe a possibility in the future that I can easily migrate to, or is it, a totally separate type of architecture and linter?
Flint will be something you can easily migrate to from ESLint, OXLint, etc. I will write migration stories. I will write tools to automate that migration as much as possible. The architectures, at least for what users declare, will be somewhat familiar and similar. None of that is true right now. Don't use Flint. For the love of God, do not use it. It is not ready. It has like 4 lint rules implemented. But no, the architecture of Flint is intentionally, I think, what I see as the best parts of the current ESLint and native speed architectures. You have granular rules, which take in the context that includes the AST. They return selectors for nodes in the AST. The config file format looks a lot like ESLint flat config, but with some what I would consider to be streamlining. Debatable whether it is better, of course. It also includes cross-file caching, of course. It doesn't allow warnings, only errors, but there will be a bulk suppressions feature like in ESLint. But yeah, I think that I personally hope and believe that Flint will only eventually be a nice successor, and it remains to be seen whether I succeed in that.
Awesome. If I were to try and pin you down, you think 2026?
2026.
2026. All right. Awesome.
I won't tell you what season, though, or what quarter.
That's too much. Before the show we were talking about video games, and but that's what publishers do. They're like, coming 2026. And sometimes they get really bold and they're like, fall of 2026. And there's like a 3 or 4 month window where you can maybe squeeze that in there.
Yep. Quarterly.
I'll tell you it's coming holiday season 2026, but I won't tell you which holiday season.
Oh, there you go.
There could be a holiday. There's lots of holidays.
February, Valentine's Day, who knows?
Yep.
Well, I did want to bring up SquiggleConf.
Thanks. I would love to talk about my conference. Fun fact, at time of recording, I'm actually sitting in the recording studio of Dimitri Metropolis, Doom and Types guy you interviewed, because I'm visiting him, which has been really helpful for SquiggleConf because we're the 2 lead organizers along with his awesome wife, Catherine. So SquiggleConf, it's a conference for excellent web dev tooling, September 18th and 19th. We have 2 days. We have a lot of speakers already announced. We actually just started posting the videos from last year, not because we were smart about using them as advertising. They just took until now to produce. So yeah, thank you for mentioning. I'm really excited about SquiggleConf.
Yes. Can people attend virtually?
No, we're going to try to figure out live streaming. Part of the downsides of having a conference in the IMAX studio at an aquarium is that as much lovely as that is, AV is hard, and especially harder for us. So I don't want to personally make any promises. That being said, A, we will record everything. All the talks will go on YouTube much sooner than last year. And B, we do have a lot of avenues for folks to attend if it's difficult. Like we have a volunteering form, volunteer.squiggleconf.com, that just went live. So if you're in the Boston area or can make it there and ticket cost is a concern to you, let us know. We'd be happy to have you on as volunteer.
Can you tease some of the talks you're looking forward to?
Yeah, we have a talk from one of the people at Void Zero actually talking about like Rust and build tools and stuff, Alexander Lichter. We've got Anthony Fu, who is just everywhere in open source. We're also a very cross-language conference. It's not just TypeScript. Sorry, TypeScript.fm listeners. For example, we have Maddie Montequila from Microsoft talking about Aspire, which is like a really cool .NET toolchain.
Yes.
Mm-hmm.
Yeah, I'm really excited about it. I think every year it's so painful to do a CFP, but the results are just incredible.
Cool. Yeah, I hope people go. That'd be sweet. I can't make it in person, but I'm looking forward to catching the talks afterwards.
Thanks. Yeah, same. I would love to be there. Are there tickets available?
Yes, there will be tickets available up to, I think, a few days before the conference. And of course, if you have difficulties, let us know. We are also trying to partner with local Boston companies and nonprofits and student clubs and such to pass them out. But yeah, one of the big things about running an independent conference like ours, so not sponsored by any one company, is that the more people who attend, the easier it is to show to sponsors that this is really beneficial. Also, the more people who attend, the better the conference, the better the crowd, the better the socializing, the networking. So please, we want you to come make this conference awesome.
I can't wait till my kids are at the age where they can just go to school by themselves, because that's the biggest blocker for me traveling anywhere. But I wish I could go to way more conferences than I can per year. But in time, we'll be able to do it.
I believe in you. I also have seen some conferences like that conf do a really good job with childcare. And I hope that becomes more and more of a thing. As once the conference world normalizes a bit financially and it's not so difficult to get sponsorships, I would love to be able to pay for like daycare or some assistance or whatever it is parents need. My organizers, Dimitri and Catherine, are parents of kids, and for them it's been hard even organizing it, given how much time goes into children.
Awesome. Well, this has been a super awesome discussion. I hope listeners learned a whole ton about linting. I know I did. I think I sort of understand now what I should be doing for my project. So I hope listeners feel the same. But we really thank you for joining us. Where can people find more about you and what you and your work on Flint?
Well, first of all, thank you so much for having me. I really, as I've expressed to you before, and I hope you remember, I really appreciate and enjoy this podcast. It's great.
Thanks.
You can find me on social media. I'm not so much on X, but on Mastodon, specifically Fostodon and Blue Sky. I'm Joshua K. Goldberg. On GitHub, I'm that too. Flint, the URL is flint.fyi, but that just redirects to Joshua K. Goldberg/Flint on GitHub. And if you want to chat with me, find me in DMs on any of those things or reach out on Discord. There's a Flint Discord that I'm happy to talk on.
Sweet. Thank you.
Thank you so much.
Thanks. Bye.
Hi, everyone. This is Kamran. I just wanted to thank you for listening to the show, and we hope you enjoyed the episode. If you want to see the show notes, you can check your podcast player or go to typescript.fm, where you'll see a list of all the episodes. If you enjoyed the show, tell your friends, and please rate it on Apple Podcasts or Spotify, because that's how the show grows and gets discovered by more people. If you want to suggest news or a project that should be covered, or just want to say hi, email us at feedback@typescript.fm. If you want to follow us on social, we're both active on Blue Sky. I'm at Kamranicus.com and Eric is at EricOnerheim.com. You can also follow the show directly at TypeScript.fm.